Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3824 called minimum k to reduce array within limit. So you're given this positive integer array called nums, and you're trying to find a minimum value of k where, first of all, for each number and whatever this value you select, if you try to reduce every number in nums to be at least less than or equal to 0, how many turns is it going to take? And then for that number, you have to basically make sure that that number itself is less than or equal to the number you picked squared. So it says that right here. And yep, so let's do exactly that. So you notice that the constraints are from 1 to 10 to the power of 5. So let's just go ahead and try every single possibility first. So first, let's define k as I, and let's just do it in the loop. And then again, right now we have nums that we want to reduce every number inside of nums to be less than or equal to 0. So let's create a deep copy of nums. And again, for each value in current, while this value is still bigger than or equal to 0, then we're going to subtract k from it, right? Because we're trying to count how many turns it takes to reduce. So let's call this turns. And that's going to count for each value how many turns it takes to reduce if we're knocking the value off by k one operation or one turn at a time. And then at the end, again, if this value, how many turns it takes, which is really this function value, is less than or equal to k to the power of 2, which it says right there, k squared, then we can just go ahead and record the current k value because we're trying to minimize the current k value, right? Trying to find the minimum value of k. And at the end, we can just return this answer. Okay, so run this. Okay, so it looks like something is a bit wrong here. So while it's still bigger than or equal to 0, then so the turns it should take, yep. So we're creating a deep copy of nums and then trying to record the minimum value of k. And k squared is just k times k, or k to the power of 2. So I guess in this case, 0 also counts as non-positive. So it doesn't really specify here. So let's try a couple of things. And again, we're trying to knock it down by k. So it's still positive. So we're going to knock it down by k, and then we're going to record how many turns it takes. So, okay, so the problem is we put turns in the loop where every single digit in nums has to be counted for each k value that we're trying, right? To knock every value down. They're not separate, right? So let's run this. Okay, so it still is probably because 0 still counts as positive. Okay, so let's submit it. And this is obviously very slow because 10 to the power of 5 is a huge number and obviously n squared time complexity. So let me show you exactly how I optimized it. So you can see you get time limit exceeded. So at least we know we're on the right track. And again, because we're trying to find the minimum value of k, why don't we just run a binary search instead, right? And then let's have the small value as 1 and the large value as 10 to the power of 5, right? And then again, while we're trying to find a k value. So we're going to try, so left plus right divided by 2. So we're going to try the middle value. So 10 to the power of 5 plus 1 divided by 2. And then again, then we're going to keep knocking down every single element in current. So let's call current to be nums, which eliminates the need for the deep copy of nums because it's not going to actually modify current itself. It's just a shallow copy. So again, while current is bigger than 0, then we're going to subtract k. and we're going to keep track of the number of turns it takes for this particular k value that we've chosen, right? And then at the end, if turns is less than or equal to, so that's this value, k to the power of 2, then we're going to shrink it because we're trying to find a lesser k value, right? Otherwise, if it's not enough, then we're going to increment the left pointer, right? And by the way, since it works here, let's go ahead and record that current k value because it could potentially be the correct answer. Because again, if this works for k, then this is a valid k, and we're trying to find the smallest k that's possible, the minimum value of k, right? So we close the right pointer because we know at least mid is going to be valid, so we don't have to check everything from mid and that's bigger than mid, right? So let's go ahead and run this. Okay, so for example, we need to do the current element, the current number, not the entire array itself. Okay, and we're using k here. Okay. Okay, submit it. So this is going to make things a little bit faster, but you can see that you still don't pass all test cases because, first of all, doing this is very slow. If we're trying to see how many turns it takes to make C0 in chunks of k, then why don't we just do turns we're going to add, instead of counting every single turn manually, C divided by k, right? And then because, for example, if we're doing 7 divided by 3, it's actually going to take... So it's actually going to take 3 turns because it can't take 2 turns, right? So we're actually going to do this so we don't have floor division instead. And we're going to add C divided by K, and then we're going to do math.ceil, right? Because that's just going to round up to the remainder in case it's not actually satisfying. 3 times 2 is 6, so we have to get 3. 3 times 3 is 9, even though it's bigger than 7, right? Okay, so let's run this. Submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.